To examine a more realistic problem, let's revisit the problem that we had in our last lesson. Once again, this is a map of a part of Long Island, and the problem is to go from Q to the end location here. So I'll call it Q problem. We have retrieved from memory the D case, which takes us from this initial location to this goal location. Clearly, this D case is potentially useful for addressing the Q problem. But it is not useful as is. The initial location of the D case is not the same as the initial location of the Q problem, and the end location of the D case is not the same as the end location of the Q problem. So we can start with this D case, but we need to adapt it. So this leads us to the overall process of case-based reasoning. The basic process of case-based reasoning consists of 4 steps. The first step is retrieval, and we have already considered this when we were considering learning by recording cases. K, nearest neighbor, is one way of retrieving cases from memory. Once we have retrieved a case from memory that is relevant to the current problem, we need to adapt it. For example, in the previous problem, we had the D case and the Q problem, and we needed to adapt the D case into the Q problem. There are many similar examples. All of us program, and all of us as computer programmers sometimes use case-based reasoning. We are given a new problem to address, and we often look at the design of a program that we have come across earlier. So that's retrieving a case and then adapting that particular design of the old program to solve the new problem. Once we have adapted the case to meet the requirements of the new problem, we have a candidate solution for the new problem. But that candidate solution needs to be evaluated. For example, in the navigation problem, when we have a solution to the Q problem, we can evaluate it whether it will actually take us to the end location. We can do a simulation. We can walk through it. As we walk through it, we'll be able to evaluate whether the solution actually succeeds in meeting the requirements of the problem. For the programming problem, once we have a new program that we obtain by adapting the old program, we can actually run the program to see whether or not it will meet the requirements of the new problem. Let us suppose for a moment that we evaluate the candidate solution and it succeeds. Then we could encapsulate the new problem and the new solution into a case and store it back into the case memory so that the case memory is constantly increasing. Notice that this case-based reasoning process unifies memory, reasoning, and learning. There is a case memory that contains a large number of cases, and that's how we retrieve cases that are relevant to the current problem. We reason when we adapt and evaluate, and we learn when we store the new case back into the case memory.